What's up, math lads? Welcome to this week's installment of Moving Pencils on Paper, until another piece of paper tells you that you can get a job. This week is a continuation of our group discussion, where we're going to talk about groupception. Groups inside groups, if you will, also known as subgroups. Subgroups are structures underneath the structures, and they're important for a few big theorems we'll be covering eventually. If you're totally lost by this point, I'd recommend looking at the previous videos, or maybe opening your textbook for the first time this month. So subgroups are just groups within groups. Let's peek at some examples. Even integers are a subset of integers, and I'll further claim that even integers are another group under addition. We're not going to change the operation, because otherwise the new group wouldn't technically inherit any properties from the parent group. It would only be the same elements, which really isn't the point. Now we know an even plus an even is even, so we're never going to leave even numbers to get to an odd number, just like you'll never leave the simulation. This means we could try to see if even numbers fit our group axioms and constitute its own group under addition. For a quick check, we have associativity. The identity 0 is even, and the inverses are negative even numbers, which are also even. So even integers do constitute a group. For another quick example, we can look at the dihedral group and look strictly at its rotations with the identity. If we only rotate, we'll never be able to mirror the shape, so we're excluded from any transformations that flip the shape, and thus we have yet another structure under this one. Not only that, but the rotations of a dihedral group do commute. This kind of comes from the literally cyclic nature of the subgroup, but that's for a later discussion. So subgroups are just groups inside of groups that maintain a closed group structure. Let's refine that definition a bit. Suppose you have a subset of G, which we'll call H. H is a subgroup under the same operation if and only if H has the identity element, H is closed under the operation. In other words, if H1 and H2 are inside of H, then H1 times H2 is in H. And for each H in H, H inverse is also in H. Now this is intuitive. It's a quick three-step process: closure, identity, inverses. But there is a way to prove a subset is a subgroup with one step. All we have to show is that if H1 and H2 are elements of H, then H1 times H2 inverse must also be in H. If we can show that that's true, then we've shown that H is also a subgroup. And likewise, if H is a subgroup of G, then H has that property where for all H1 and H2 within H, H1 times H2 inverse is in H. Remember, this is a biconditional statement, so to prove this, we have to prove both directions of the biconditional. Proving the first set of rules implies the second one-step process is kind of trivial. Since inverses and closure are given, we can show that H1 times H2 inverse is in H. So how does this one-step process imply we have a subgroup? Well, now we have to assume that if H1 and H2 are in H, we know H1 times H2 inverse is in H. And we need to show that H is closed, and the inverses are contained in H, as well as show that the identity is in there. Let H be in H. Since H, and redundantly H, are in H, H times H inverse must be in H, by our assumption. But this is the identity, so that's E. Since we have the identity, we can show that since E and H are in H, this implies that E times H inverse, which is equal to H inverse, is also in H. We now have inverses. Now, to prove closure, consider that if H1 and H2 are in H, then H2 inverse must also be in H since we have inverses. So, H1 times H2 inverse, which is equal to H1 times H2 is in H, which means we have closure. Now, all of this still hinges on H being non-empty, so technically that's a step 0 before step 1. But otherwise, you can now freely use this test to prove something is a subgroup. Now let's look at a couple more examples, because what use is theoretical knowledge if there's no problems in the real world that are solved by it? Said no mathematician ever. For a moment, we're going to look at the complex plane. C star is the group of non-zero complex numbers, which we'll consider a group under multiplication. The subset 1 minus 1, I minus I, is also a subgroup. Under the operation, it has the multiplicative identity 1. Each of the inverses exists within the subset, and if we multiply each possible pair of elements, the result will be in the subset. Let's take a look at Q star, the set of non-zero rational numbers. Q star is also a subset of C star. Let's use the one-step test to determine if it's a subgroup. We know Q star is non-empty, so let's assume we have two rational numbers, A over B and C over D. If we observe C over D inverse, it's D over C, and if we multiply A over B times C over D inverse, we get AD over BC, which is a rational number that is non-zero. This means Q star is a subgroup of C star. So the same group can have several different subgroups. For now, we can safely say every group has at least two subgroups. These are trivial subgroups. The first is the group containing only the identity, and the second is the group itself. Now, it's important to recognize that not every group has non-trivial subgroups. Specifically, groups with prime order do not, but that's for another lesson. The mathematician inside you is growing. Progress is slow, just like the rate at which these videos come out, because I'm a busy person with important things to do, like napping, or laying in bed doing nothing, or pushing myself to post on Instagram or Facebook for the sake of validation, or trying to write music for these videos, or creating small Python scripts that have a hidden joke for a few seconds, or stressing over the inevitability that there will be mistakes and blunders that you will most definitely find, or wondering if anyone actually gets any information or benefit from these videos. Just cue the outro music. Anyways, I hope you enjoyed this video. If you haven't already, please subscribe to the channel and leave any thoughts you have in the comments down below. Thank you for your time, and keep learning.